In section 5A, we're going to look at 3 different activities that all center around the same concept of researchers trying to collect data. In the first activity, which I'm going to title up here as 5A1, I don't know why they didn't have titles there, we're going to look at defining 4 things: the population, the sample statistic, and the population parameter. Of those 4 things, the one that seems to be the most difficult to explain to students and somewhat explain to myself as well is the population parameter. So as we're going through this, be aware that that's my opinion on it, and whenever we talk about population parameter, maybe give it just a little bit more consideration in what we're looking at. When researchers decide that they're going to collect data, one of the biggest obstacles that they end up having is trying to obtain information about what is called the population. The population is a complete group, which is usually really, really large. Okay, so it says here large populations. A complete group that is really large, and you want to know information about them. But that group could end up being so large that it's just difficult or possibly impossible for you to check with every, let's just say that they're people and they're doing a survey. So it might be impossible to make contact with every person in that population. As an example, Americans. If you just wanted to ask a question about all Americans, it is not going to be likely that you can make contact with every American and get an answer from them or a data point on something like that. So then what we do is we choose a sample. A sample is going to be a smaller group of the population. It'll be a size that we hope is going to be enough. I mean, it's not going to be nearly the same as what the population would be, but we hope it's going to be large enough and it's going to be a good representation of the true population so that what we learn from the sample is of value. Then you go out and you carry some sort of research or an experiment and you get back some numbers. The numbers that you're going to get back are called the sample statistics. It's down here. You're going to get back information called the sample statistics. Those are going to be the actual raw numbers that you get from that research. Then the confusing one here is that those sample statistics we want to use as numbers that represent our population parameter. So the population parameter, the way that I like to define it here is it's the question that we want to answer. So the population parameter is almost like the stats about the whole population, but since you can't do it, we actually more or less phrase it in what is it that we want to learn sort of thing versus something that we learned. In problems 1, 2, 3, and 4, what you're going to be doing is just identifying from these descriptions what would be the samples, the population sample statistics, and the population parameter. If you didn't notice when you're working on this previously, the underlined parts in the statements are actually going to be the answers that go with them. So if you didn't notice that and you weren't able to get any answers here, maybe give that a try before you watch the next little part of this video. Okay, number 1, a presidential candidate wishes to know his approval rating among American voters in the age bracket of 18 to 24. He hires a polling company who contacts 2,096 registered voters in that age bracket. Now, 2,096 is a good number of people, I think, to get some information out of this thing, but it does not come close to being every single voter in that bracket. So the population is the American voters from 1824 range, whatever number that actually would be. The sample is going to be that 2,096 voters that they actually contact. Question 2, a manufacturer company randomly selects some dealerships in the Midwest. So right there, that some dealerships, even though it's not an actual number there, some dealerships in the Midwest is going to be your sample because it's not all of them. And they're going to gather data from the sales on the car sales and weather patterns. They wish to know if dealerships in severe weather areas have higher selling rates following significant weather events. So the population that they're looking at is all of the dealerships, that have like severe weather in the areas, and then finding out what happens. So I guess they chose the Midwest because the Midwest might be more prone to like tornadoes and things like that. Okay, so the part that I think can be a little bit confusing is going to be the sample statistics and the population parameter. One of the easier parts, at least with the sample statistic, is to be looking for a number amount. It's not always going to be there, but generally that's what it will be. Okay, so these then follow the same problems that you looked at above. So we're back to the presidential candidate, and he's looking for his approval ratings. Okay, so this is what he discovers. The polling company finds that 39% of the sample approve the candidate. So that number, which is corresponding to the sample group, is going to be the sample statistic. So it's nice that they named it that way. The population parameter is not going to be a number. So the way that I believe it is defined is it's what we gain from the whole population. So usually the way I think of this is it's more of a statement or a question that we're looking for, and you can see that it's underlined up here. So by default, this will be it. It's his approval rating among American voters in the 18 to 24 age bracket. That's the thing that he wants to know, but you don't actually get a value from it, and you never do, because that's the whole concept of we can't talk to every single person in the age bracket. So we're doing a sample and getting a sample statistic. If you could, like, survey every single person that's in your group, then your population parameter could be answered as a number like a sample statistic. We won't see any of that though occur. All right, the dealerships average of 12 more cars per week. So after these weather events, we start looking at their sales, and you get this hard number here that the dealerships in the sample, so it kind of gives it away right there. The dealerships in the sample is an average of 12 more cars per week, so that's your sample statistic. And what they wanted to find out was the selling rates following significant weather, so that's going to be your population parameter. And again, that's a statement, and that one's not really a number on there. By the way, what I wrote down here is just kind of paraphrase what it says there, but it'd be nice if your answers were completely the pieces that were underlined, and maybe even a couple more words to go around that. Page 2 puts all four of these things together, and we start looking at it as a flow chart in an order of how we're going to do things. One part that I think, well, I'll say it at the end here, but one part I think that's kind of weird is how the population parameter falls within their that kind of cycle here. All right, when you're going to conduct some research, the very first thing you're going to do is try and identify what the goal of your study is. So up here it says start, and you're going to identify whatever your goals are, and that's going to lead you to thinking about a population. So if I want to know about approval rates of a politician, then that's going to be my goal, and from there, I need to think about what's my population, the people who are voting. After that, once you have your population, you're going to choose a representative sample over here. In the next activity, we'll talk about how you actually choose that sample and different methods that you could use for it. And once you have your sample, you can go ahead and carry out your research. You're going to get some numbers that are based off of the sample, which are called the sample statistics. Then those sample statistics will be used to make inferences about the population, which is what we call the population parameter. This is the part that I think is a little bit weird, because the population parameter is kind of like the goals that you're coming up with anyway. What is it that you're trying to ask? So goals is sometimes presented as, what is it that I really want to know? And in that statement, you kind of are using the population parameter to make that clear to yourself. Okay, so here, you got a long one, but again, notice everything was underlined. All the underlined parts are going to end up being the things that we fill in here. Let I'm gonna work under the assumption that you read this, and it's about copper bracelets being worn and whether that helps with arthritis of the hands. The population that we were going to be looking at were people with arthritis in the hands. Okay, now we can't sample every single one of these people in the world. It'd be pretty crazy if you could. So what they do is they grab a sample, which is going to be 279 patients. So your sample, 279 patients. They give you a little bit more room to fill in the rest of that sentence, but I just kind of jotted the main point to it. The sample statistic is what we learned from those 279 people, which is a 1.5 point on a scale of 1 to 10, 1.5 point decrease in pain, average pain rating. So that's really subjective, and we'll talk in other activities about how do we really measure these numbers and buy into them. But that's what it just says here, so roll with it. You've got this for the group that had the nickel-plated bracelets. You had no change for those in the third group, which you'd probably assume to be true because these people aren't even walking around with a bracelet on their hands. I think that's how it said it. Yeah, because it says that they wear no bracelet for 3 months. So what are you going to gain from that or think that they might gain? Okay, then population parameter, as you'll see here, is kind of... even in their worksheet, they realized that it's kind of hard for you to pull that from the sentences here. So what they did is they went ahead and filled it in for you and then just had you call that the population parameter. But again, it's that, what do we want to know? It's the changes in average pain ratings in people with arthritis. Like, do these bracelets make any effect on people? And then when it's all done, you can look at the data and you can draw your own conclusions. This one just said that the bracelets don't appear to show any significant changes and stuff. I guess the numbers are too close to call. I think that the whole survey on its own is a little bit weird because it's more psychological, I think, than anything else, at least as far as I understand that stuff. Okay, so then we basically do the same thing again. Let me cover up some of this as I go through it. We do the same thing again, but without all those pieces underlined and just being handed out to you. Okay, again, you should have read this, but the premise of number 6 is that educators often believe that requiring uniforms in K to 12 grades will improve academic performance. And yes, we're going to carry out a study, and the way the state did this is they took what they are calling a random sample, so they don't really describe how that's actually done. We talk about some of the methods in the next activity. They're going to take a random sample of 200 schools in its state. Now, one thing that I needed to figure out as I was going through this is that random sample of 200 schools is going to be of schools that do and don't have uniforms, and they're just going to do a comparison on those. So what I did not, what I originally thought here, but I don't think is what's going on, is that they took schools and they required those schools to start wearing a uniform, and then they reassessed how those kids did with their GPA. I'm just reading over that to make sure I said that right, and I believe that is true. Okay, let's see, your population is going to be all students in grades 12 through K. Can't sample them all, so we choose a sample. The sample that we're going to use is that 200 randomly selected states, schools within states, sorry about that. So we're going to choose 200 schools in the state, supposedly by random, claims it's random here. And I wanted to make that note again here that we're not forcing the schools to wear uniforms and then see how they did before and then after. But what we're just going to do is a comparison. So some already have uniforms and then some do not, and you're doing a comparison between those two things. The sample statistic is going to be that number that you come up with here. The GPA in schools with uniforms is 0.3 points higher. That is not a big number. A GPA score ranges from 0 up to 4. Basically, that would be the difference between somebody having an average grade of a 90 versus a 93. So the 93 would be that 0.3 points higher. So I wouldn't say that that's a significant change here, and we'll see that in our conclusions. Number 4, what's the population parameter? Again, this is what we're trying to figure out. Do uniforms cause students to have better grades? Okay, whether requiring uniforms improves the GPA. Then 5, drawing the conclusions. A lot of this is kind of debatable on our own. I would say that it doesn't really show much of a difference. Does it actually tell us that in here? No, this is fine. So I don't think that there's an obvious shown here that if you have uniforms, you're going to do better. And then there's a lot of other things to kind of consider about how this whole thing was posed, that they were just taking from schools that they already had. Hint for the next activity, that's called an observational study. They're going to look at schools that are already done, and they're not going to force something to happen here. They're not going to conduct an experiment, so it's called observational study. And when you do those things, observational studies, you could find this kind of interesting thing here called confounding variable, that maybe there's more to what's happening than the fact that the kids are wearing the uniforms. In this case, I think that would be true because generally speaking, the schools that have uniforms are not going to be public schools, but they're probably going to be private schools or some other similar type thing like that. And that means that the parents paid for the kids to go to school, which probably means, or maybe they didn't even pay for it. It might be a type thing where they got a grant to do it. But that might already start to tell you that in their home life, there's a social understanding called social norm, a social understanding that education is highly valued and they need to do good in there. Where on the other end with public schools, there will be, I think, more students there, at least that's my experience, more students in public school that they just go because they're required to go. Question 7 is going to be, I guess, similar to number 6, that you're going to take your own information out of the text. I should hide that too. You're going to take some of the information, you're going to take information out of the text and just identify these things without it being handed to you. A Gallup poll, and this one's real vaguely written here, so I found that kind of as more of a challenge. A Gallup poll of 1,051 Americans showed that 32% of Americans say that they have been spending less in the recent months, and 27% say that they're saving more and intend to make this their new normal pattern in the years ahead. So the population that we're going to just be looking at is, actually I kind of do this a little bit backwards. What I'll do is look at the sample because that number is so just there for you, right? Your sample is going to be that's why I now remember why I color coded these here. The sample is going to be the 1,051 Americans. Right, that one's easy to pick up. So if that's the sample, then the population, you can kind of just take out the number that goes along with it and say, okay, the population is Americans. All right, then you get these percentages, the 32% that say they're spending less, the 27% say then save, and they're going to do more saving. That's your simple statistic. Those are the numbers that you are getting from that 1,051 people. Okay, so then the population parameter is trying to say, what is this stuff with respect to the Americans? What is that? And going back and forth and reading it a few times, we know it's about spending habits. But a little bit more with that is, it's the spending habits of Americans now versus a few months ago. Because it does say are spending less in recent months. Okay? And what the people expect to do as a normal pattern for the next year. So they must have been coming back and asking people, well, they didn't come back and ask people, but they asked people, hey, from before, how has things changed for you? So I want to make sure I included that now versus a few months ago, parts of that. 5A2. This one's a short one. I thought this one was evolved and it's kind of the more enjoyable because you're doing a little bit of a matching thing here. And And I wish that we were in class so that we could do maybe like a little cutout and move them around and match them. I always thought that kind of hands-on stuff's a little bit more exciting, but here all I really got to do is draw lines. I did a couple of them in pink, so maybe it would be an easier way to distinguish how they're matched up with each other. Usually when you think of just a random sampling, so anyway, what we have here are 4 different ways that you can take samples. So I mentioned in the other one that there's some things that we don't know about, like how do they get those 200 schools that they chose? Okay, well, these may have been methods that they had used on there. They refer to it as a random sample is what most often that you hear. A random sample is supposed to be all of your population is put into a big pile and you're just drawing out a certain number of them. The only true way that I know of like doing that one, like the most easy example is just to have a big list of names, and I describe it as drawing from a hat. I'll use that in a little bit here. That if you just dumped a bunch of names into a hat, sort of like how I shuffle you guys into groups when we were in class, I would just have a big stack, and then taking from that stack, I would just draw out certain names, and that's what random sampling is. Everybody's there and we're pulling from them. So the one that best fits that one is going to be the this computer company that just selects 25 employee ID numbers. Now, if you have to do one of these problems later on, what I would suggest is you try and find the other 3 first, or if it's where you're just trying to state the name of which one you're doing, just eliminate the others based on very particular characteristics that they have. Because sometimes when you write the sample, the random sampling, you get a bit more information and it almost wants you to choose another one, but there's ways to eliminate those others. The systematic sampling, for that, what you do is, well, they kind of give you the best kind of method of describing. You choose every 10th of 50. So if you needed 5 things chosen and you got 50 of those things, then just count them off. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're gonna take you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're gonna take you, and that would be a way of doing it. It may or may not be much different than random sampling, depending on how things are lined up on there. In other cases, you'll see the answer that goes with that one. All the people that are in this thing already have a number that's sort of assigned to them randomly as well, which is their apartment number. So they use the apartment numbers to choose the people. So there's a number that was assigned to them. So maybe that's a little bit better than just trying to count things off, but it's still a sense of randomness, I believe, in there. Convenience sampling is usually really easy to identify. Did the person who is going to get the information try and find some way to make it convenient? There's a word, convenient for them. That's going to go up to the top one, and the dead giveaway is, it says they went to the closest, the 3 polling locations closest to the studio. Okay, and that may be a really bad way of getting information, because we all know that we live in, like, different demographics tend to live together in places. So if you all go to the same location, you know, like not really spread out much, you're probably going to get more likely data that's similar than if you were to really spread out and try things. Okay, stratified. The main thing that you look for that is you're considering a little bit more about the sample and maybe the population that you're looking at, and whether you have small like subgroups that make a difference in these things. And the problem could be is that those subgroups from one to the next, say Democrat versus Republican, that you would expect certain answers from one subgroup. So you want to do sort of like a nice split with that one. That one you're going to notice has the longest description. I don't know if that's a trend. I kind of felt like it was when I was doing the problems, because they really need to break down all the things like what are the subgroups that we would see. What was this one about here? Leave students, about transportation. I think it had to do with the fact of people who might drive and who don't drive. So you have 2 obvious different groups, and if they're going to ask you about transportation, then you should be aware of people who drive their own cars and then people who don't drive their own cars. I didn't read that right now, so I hope that's how I did recall it. If not, that still sounds as a good way of describing it. All right, then for the next page, what you do is get to come up with your own ideas on how you would do these different types of samplings. We're not told what the question is that we want to get from it, so that only caused me a little bit of trouble in the stratified, there's no S in there, stratified sampling. So we're just looking at choosing 5 people from our class for some question. Random sampling, like I do with the little cards in our class, if you just had a stack of names and you mix them up and then you just draw them. So usually we call that as just to draw a name from a hat, whether you have a hat or not, so quotes. Systematic sampling, usually you're going to count people off, do something like that. I was trying to imagine in our class that when I still do like counting 1, 2, like count to 3s and then break you up in certain groups, when I would do things like that I don't really think is too much different than simple random sampling. But I guess it was, so I thought I'd maybe add just a little bit more to it. Maybe what we'll do is put everybody by age and then take every blank number person. The thing about that is it starts to get into the stratified sampling as well, that if we were concerned about ages, then maybe not. So, so systematically, just something about how you maybe line people up and you just count them off, sort of thing. Convenient sampling. Let's take the first 5 people that walk into the room. That'd be a way to do it. Just like get real lazy. Usually this means laziness. Nah, you. We'll just grab you, kind of thing. And maybe today, so if we're sitting all in our classroom, then it's just like, oh, just take everybody that's sitting in the front. And that'd be fine. All right, number 4, the stratified sampling. You really got to look at what your groups are. So this is something that we don't know in this like actual thing here, but maybe you should think of a few that you believe could be things that we normally ask about. In our class, I think age, we definitely have students that are right out of high school, and then we have students who are coming back after some time here. So your opinions about life are probably going to be different, and if we're asking some question like that, then you might want to break up into 2 groups and take a little bit from each. Gender, obviously that could be a difference in a lot of things that we talk about, and then like political groups, Republican, Democrat, or whatever. 5A3, despite the fact that it's super wordy, I believe that's true on all the pages here. Oh man, besides the fact that it is super wordy on this stuff, I actually think this one's kind of fun to look at, because it really comes down to like an A or a B choice in problems. Do we have what is called, let me move down to here, do we have what is called an observational study, or do we have what is called an experimental study? Most of the studies that you're going to think about, especially when we use the word study behind it, is going to be what we call an experiment. The most classic case to look at for that is medication. We want to test to see if a medication is going to work. When we do that, we're going to take a group, a sample of the population, we're going to take a group, and some people are going to get the medicine, and some people are going to usually get what's called a fake pill, or if it's an injection, then it would be just like a saline injection. But you have one group that actually gets medication, you'll have another group that gets something that is can't do anything for you at all. Placebos are normally, I remember this as a kid, were sugar pills is what we would just actually call them. Okay, so at the beginning, and I like how they introduce this here, they just let you read about studies and then ask, well, what do you think's different about them? And then from there, we introduce the vocabulary words and then have you choose. I didn't really talk about the observational study, so let me come back to that one. In an observational study, the researchers don't impose anything on this thing. So in an experiment, you say, all right, you 50 people take medicine, you 50 people aren't taking medicine. Of course, we're not going to tell them that, but that's what we're thinking. 50 get medicine, 50 don't get medicine. Now let's conduct the study. In an observational, you don't do that. You don't force something on people. People just naturally fall into categories, and then we look at the data that comes from that stuff. So the observational study ended up being B, which was about, I got to read it here now. Researchers could randomly select 10 large colleges and then randomly select 50 students at each college from sections of particular algebra classes. So all of that, just kind of go back to the last activity, that is kind of like a stratified sampling. They want to choose people that are also from different classes and kind of well balance all that stuff out. But the students will be asked to record their daily food intake for 2 months. So that part right there is what tells you that it's observational. The students are doing what they want to do. They're doing what they want to do, and then we're going to look at that information and assess whatever the rest of this said here. The experimental is going to be the first one, and you're going to be able to identify that because it says they're going to put people into groups right there. You divide people into groups, however you randomly did it, it's fine. But the first group is going to be told to do one thing, like to eat 1 serving of dark leafy greens for 4 days per week for 2 months. And the other group is told not to do it. Don't do it. Don't add anything, don't change anything, just let it all be as it is. So within those experiments, there's 2 groups that we always want to know, the treatment group and the control group. And I've always felt that the names fit fairly well. The treatment group is the one that gets like the medication. I'm putting that in air quotes, medication. Okay, so like the leafy greens is the medication. So anybody who had that is your treatment group. And then the control group is always the group that doesn't do whatever. So you're going to see that as a consistency in almost all the answers, that does not, did not, something did not occur for that one. And the treatment's the one that received whatever it was. All right. Maybe I should cover up some of these too. Don't look. Okay, there's a little typo here. It's not Rick. It's Risk. Okay, the National Cancer Institute study found that group having a single large mole had twice the risk of melanoma, which is a type of cancer, as compared to a group that didn't have a large single mole. Above that, what it did, sorry, I had that all crooked. Above that, what it does mention is retrospective and then case controlled. So when we do an observational study, it can fall into 2 little categories. And retrospective, case controlled. Let me see, I'll talk about case control first. Case controlled seems to resemble an experiment where you have 2 different groups, where one of them you could sort of treat as a treatment group and one as a control group, one that has and one that does not have, sort of thing. The retrospective, we'll see what that one looks like in a little bit, because this first problem is actually your case study. Okay, so things that have and things that do not have. So there is a group that have a single large mole. There's also a group that didn't have a single large mole. I think it's forgetting the word have in that spot as well. So the have not, that's going to be your case and your control. So control, the words, similarity is still going to be the ones that do not have. So they don't have the large single mole, and then your cases will be those who do have the large single mole. So it looks like an experiment, but you can't actually really conduct it as an experiment. And that's what this next question, which I thought was a little bit hard to answer, is about. It says, why would it not be possible to run an experiment for this? Why do they have to leave it as an observational study to do this? And the way my mind eventually got around it was to say, well, if we're trying to test to see if having a single large mole increases the chances of having cancer, then the beginning of this whole thing would be to find all the people that have, or as many people as we can, that have large single moles. And then to study them like into the future to figure out which people ended up getting cancer from it, skin cancer. Well, doing that, you might not really get good data. I said there's too many people to get good data. You're going to have so many people that have a large mole that don't get cancer that your percentages are going to be incredibly low and hard to learn from. But if you do this as an observational, then what we can actually start with is people that have cancer, and then look at those people with cancer and say, did they have a single large mole or did they not? And then based out of those just people who have cancer groups, you might be able to come up with that twice kind of thing, 2 times as likely to occur. What do we got next? We're just going to choose if it is observational or not. Let's see, travel agency. So again, you should all have read this, so let me paraphrase because I do remember this one here. Travel agency is putting together a pamphlet on the safety for customers. They hire a research firm to analyze the random sample of 300 people who will have traveled last year. Then they'll look at people that put locks on their luggage and people who did not put locks on their luggage. Okay, so number one here, is it observational or is it experimental? Well, the fact that we did not tell people to put locks on their luggage and people not to, and then learn from there, okay, that's going to be observational. People naturally fell into their own group of either putting the locks on or not putting the locks on. So this is going to be observational. So then to follow that up, this type of observational is a good example of a case-controlled study. The case is going to be the doing, the control is going to be the not doing. So case is going to be putting locks on, control is going to be no locks. And next, this is going to be experimental. You may notice it's a lot longer because for the experimental, then they tend to give you more information. Let me see if I can find that key phrase here. Randomly divided into 2 groups. That means that somebody doing the research decided to say, you're in this group and you're in that group. They might not know which groups they're in, you can do these blind studies and stuff, but somebody stepped in and said, these people are going to do something, these people are not. It's not a natural choice by the people that they would have been observing. So this is the experiment. And this one's the green tea one, yeah. Okay, so the experiment, your treatment group is going to be people drinking green tea, and your control is going to be people not drinking green tea. I think we're moving to the last part here, which involves confidence intervals here. Okay, so if you did not take time to read over the table, try and do that and to process what it says. But I'll go ahead and give you a quick overview of it. They looked at a lot of people that have vacation days that they're allowed to use. One key word here is that it's paid vacation. So when you're going on the vacation, you're not losing money. So that's not kind of something involved in the choices here. But they broke it into these categories of low-paying jobs, average-paying jobs, and high-paying jobs. And they just wanted to ask what people end up using most or all of their vacation days allotted to them. I would believe that in the data, there's some of this, what we referred to earlier as confounding variables, that other reasons aside from maybe just the fact that how much they get paid, which would contribute to all of this as well. But they're trying to see if how they get paid is that comparison. And, low paying jobs, they had 39 people, or 39% of the people say, yeah, they use most of their days, if not all of them. And then 51 for average paying and 52 for the high paying ones here. Question 8, is it observation or experiment? Straight up observational. Look, experimental, you got to put people into groups. So you're not putting people into certain paid positions, and you're not telling people like to use days or anything like that. You're just looking at what's happened. Okay. And I think this is a good example of something that is not a case study sort of thing. These are just people falling into their natural groups, and they're just doing something or kind of not doing it. But we're not looking at the comparison of when things happen or not, like whether you locked luggage or not. It's just people are making their own decisions here. All right, number 9, we cycle all the way back to the very beginning of our 5A notes and ask you about sample and the population. The sample was up in the top prompt, and it said that it was 1,219 workers that they chose. So the population is going to represent all workers. It looks like they're considering all the different classifications of paying jobs, low to high. So I'm just going to assume that it's going to be all workers here. Question number 10. These numbers as percentages, right? Are these numbers population parameters, sample statistics? They're sample statistics because these are the numbers that we're getting from the 1,219 people. Okay. But then what we do is we take those numbers and we infer them onto the population, and and you could apply those numbers directly, say, hey, all people in low paying jobs are going to have 39% people use all their vacation days and stuff. But really the population parameter is just the question that we're asking is how much vacation days do people use, depending on what pay scale they're in. And notice that they didn't ask you to write that one, because that's always kind of hard to do. It's easier to identify the sample statistics than it is to make a statement on what that population parameter is. All right, 11, they start having you look at the fine print, and now we're leading into a little bit of how good is data when we're collecting it. It says that it was a random digit sampling. Random always sounds nice. It's one of those words, buzzwords there. Random digit dialing, and they call people through the cell phone, and they also use landlines. So that was nice, right? They didn't limit to just people with cell phones, because not everybody has cell phones. Some have landlines, and maybe they're more likely to answer phone calls through that. So that was a good idea. But it says, do you think that that they gathered a true sample randomly from all of this stuff here? And I wanted to make this statement here first, that there's always going to be an issue. There's always going to be, and you're going to try your absolute hardest to get things to work out when you're conducting research, but there's always going to be a little reason here. And here's the idea that I thought of, that people have to answer the phone. If a number calls me and I don't recognize it now, I don't answer it. Unfortunately, I end up missing a lot of really important phone calls, and then have to go to the voicemail and see who I've missed things out. But if I don't recognize the number, then I'm not going to answer it at all. And I bet that there's a lot of people out there that are the same way. So the data that they're going to get here is only going to be based on people who decide to answer the phone and want to. And then somebody says, hey, will you take a quick survey? And you're like, yeah, sure. I'll take a survey. I got nothing else to do. Nothing else more enjoyable. So I think that, there's going to be some issues in like who they're speaking to, and that becomes also a confounding variable as well, like who's going to want to do this. All right, and last we're going to talk about what is called confidence intervals and margin of error. Okay, so also in the fine print, it says, let me go back to that one. It says that there's a margin of error of plus or minus 2.9 percentage points. What that means is that any of these numbers that you see here, that's what they're using as the representative, but they believe with confidence that it actually could be 2.9% higher or 2.9% lower than that one. So it's in this case, it's a small window, which is pretty good, but they want to be like fair with it. So these numbers could all be wrong by 2.9 in either direction. As an example, the 39% could have actually been 2.9% lower. I did that as mental math, so I hope that ended up correct. or it could be 2.9% higher. So within those ranges, which I don't think is too big of a window when you look at that. It's actually 5.8 if you add 2.2 and 2.2. So 5.8% variable range in there. But what about the other ones here? The, where was it? I might have misread that part there. Is it reasonable to say that the majority, oh no, I did right. The majority, or 50% or higher of Americans in low-paying jobs do not use most of their vacation days. And I think yes, because if you go with the regular number that they gave you, 39%, that means 61% did not use all those times. And even with that confidence interval, like if you took the high end and subtracted that one, you're still going to be fairly well over the 50 mark, almost at 60. You're so close to that number. So I think that's fine as a statement you could write. But then the other ones that are around the 51 or 52%, you should say no. So the average one, if you do the 51 up and down, you're going to get these numbers, and that's literally right around the 50%. So is it reasonable to say that the majority of Americans in average paying jobs use most of the, no, it's not. It's like right around about half and half, okay? All right, then I drew a little line here at 15 because we actually reset into a new problem, and 15, 16 will be different. This one's kind of crazy here. Approval rating is about 54%, 55% with a margin of error of 32%. Geez, that means that if you were to subtract 32% from this and add it on, that gives you a range of values that we feel this could be correct. And look at that, 22% to 86%, that's the approval rate, and somewhere within that window. Is that useful information? Absolutely not. It doesn't tell you anything like any like real area. Yeah, so if your margin of error is a large percentage, then it's not helpful. Something is wrong with how that is conducted. All right, and now last one here. They state things differently at the beginning. 584 Americans were asked about pet ownerships, and it was like, it said from 40% to 48% of Americans own a dog. So that's kind of how they closed it off at those numbers. I don't know if that actually was the minimum number that they read, the highest. Maybe there's a little bit more calculation to it, but they put it within that range there. So the sample statistic, they want us thinking backwards, is just to split that in the middle, say 44% is what we got. How many people in the sample owned a dog? Well, if I take 44% of the 584, you're gonna get 257. It was actually that number, but I wanted to show you that and then let you see that I rounded it up. The margin of error is gonna be that difference from the center to the high and the low values that you'd have there, which would be 4%. Then I like this question here, write your own sentence that kind of summarizes what we learned from there. With a margin error of 4%, the Gallup report shows 40% of Americans own a dog. No, not 40, 44%. Look at that, I made it all the way to the end of the activity and then made one mistake, at least that I saw. Yeah, 44% of Americans own a dog, so then you could go up 4 and down 4. Supposed to be that number. All right, that's 5A.